Hi, this is Adam Griffin, and this is the second video for this week of physics videos, which is week 6. So we're going to be doing question 42, which involves Newton's second law and first law. So the question is, seatbelts and airbags save lives by reducing the forces exerted on the driver and passengers in an automobile collision. Cars are designed with a crumple zone in the front of the car. In the event of an impact, the passenger compartment decelerates over a distance of about 1 meter as the front of the car crumples. An occupant restrained by seatbelts and airbags decelerates with the car. By contrast, an unrestrained occupant keeps moving forward with no loss of speed, Newton's first law, until hitting the dashboard or windshield. These are unyielding surfaces, and the unfortunate occupant then decelerates over a distance of only about 5 millimeters. So the first part is a 60 kilogram person is in a head-on collision, and the car's speed at impact is 15 meters per second. Estimate the net force on the person if he or she is wearing a seatbelt and if the airbag deploys. So we are traveling at a velocity of 15 meters per second, and we are stopping, going from 15 meters per second to 0 in 1 meter. So in 1/15 of a second, the car will stop. And if we divide that by this initial velocity, we get acceleration, which is mass divided by seconds over here, or meters per second, pardon, divided by seconds, which will give us meters per second squared. So that comes out to 225 meters per second squared for our deceleration. And since our person weighs 60 kilograms, we just multiply that to get it in newtons. So the person with airbags decelerating over 1 meter will experience 13,500 newtons. So quite a bit. And then for part B, we are decelerating over 0.05 meters or 5 millimeters. So with that, we only have 1/300th of a second to go from 15 meters per second to 0. So if we have 15 meters per second divided by 1/300th of a second, we get 4,500 meters per second squared. And then we multiply that by the mass of our person, and we get 270,000 newtons for the force that they experience. So really, all this is talking about is Newton's first and second laws. So we know that if a person is moving with the car, and the car stops, they will continue to move because there's nothing holding them down. So that is how you do question 42, and thank you.